Now we're ready to talk about another foundational area in Power BI, and that is adding calculations to your data, which will ultimately be available for your users through reports and dashboards via metrics on your visualizations. We will discuss creating calculations with DAX. DAX stands for Data Analysis Expressions. It was designed by Microsoft and can be used in a lot of Microsoft products. We'll talk about what DAX is, what is a measure. We'll also focus on the different types of measures and the calculated columns and tables coming up. Data Analysis Expressions is a programming language that is used throughout Microsoft in Power BI, Excel, and SQL Server Analysis Services, or SSAS. It is used in Microsoft Power BI for creating measures and calculated columns and tables. It's a collection of functions, operators, and constants that can be used in a formula or expression to calculate and return one or more values. You can use DAX to solve numerous calculations and data analysis problems. In Power BI, you can use different calculation techniques and functions to create measures or calculated columns. The key to DAX in Power BI is to know how and when to apply them. We need to first get your calculation to work, then go back and see if we can make it work better by optimizing it. So by having a basic understanding of when and how to use which technique, you will be able to create robust and high-performing data models. This is important because complex calculations can slow down Power BI queries. Measures in Power BI are essential for performing calculations and summarizing data within a DAX model. They enable the aggregation of values across multiple rows, allowing for a comprehensive view of the data. Measures are commonly used in data analysis and offer a wide range of functions, including sum, average, min, max, count, and more. What makes measures particularly powerful is that they are not pre-calculated. Their values are determined only when queried for. This dynamic nature ensures that measures remain up to date and in real time, responding to user interactions within the report. This dynamic behavior is one of the key advantages of the Power BI reports. By creating measures and combining them with filters and other visuals, users can explore the data and generate insightful visualizations. The measures are indicated by the calculator icon here, indicating an explicit measure, or the sigma icon we're showing here, an implicit measure. They are also defined with DAX definitions, as we'll see going forward. Since they are calculated when they're used and on the fly, they're not stored in the data model. Here we see the profit measure indicated by the calculator icon along with the syntax here. The calculation here is summing the sales field in the sales table and subtracting that by the sum of the cost field in the sales table to produce the measure profit. By default, Power BI automatically aggregates numeric columns using functions like sum, average, min, max, count, or count distinct as the default summarization. This automatic aggregation is called an implicit measure, indicated by the sigma symbol. You can modify or disable implicit measures by adjusting the default summarization settings. Explicit measures, on the other hand, are intentionally created measures where you define the calculation in the formula bar. With explicit measures, you have full control over the calculation logic and cannot modify the summarization once defined. They are indicated by a calculator icon outlined here in red. Lastly, quick measures are predefined calculations in Power BI Desktop designed to assist users. While they offer a limited number of available calculations, you can easily select the appropriate fields, and Power BI will generate the measures for you, helping you to learn the DAX syntax. Here we have an implicit measure called cost. Notice the sigma in the data pane on the right. Notice that once it's selected, you can go up to the ribbon and to the Column Tools menu and change the summarization to another option in the list, like sum, average, min, max, count, count distinct, or even don't summarize. To create a quick measure, right-click the ellipses and select New Quick Measure off the data pane in the Power BI desktop. You can then select from any of the quick measures available as shown on the right. To create an explicit measure, right-click the ellipses and select New Measure off the data pane in the Power BI desktop. Then use the formula bar to type in your DAX measure syntax to create an explicit measure. Here we are creating a total sales explicit measure, which is summing the total price field of the sales order details table. Your total sales measure now appears in the field pane, and it is ready to be dragged on to the report into your visualization. Explicit measures can be created in the report view, model view, or data view. The fundamental difference between a calculated column and a measure is that a calculated column creates a value for each row in a table. For this reason, the calculated column can only operate over columns that exist in the same table. For example, if the table has 1,000 rows, it will have 1,000 values in the calculated column. Calculated column values are stored in the Power BI PBIX file. Each calculated column will increase the space that is used in that file and potentially increase the refresh time. Measures, on the other hand, are calculated on demand. Power BI calculates the correct value when the user requests it. When you previously dragged the total sales measure onto the report, Power BI calculated the correct total and displayed the visual. Measures do not add to the overall disk space of the Power BI PBIX file. Measures are calculated based on the filter that are used by the report user. These filters combine to create the filter context. Ideally, you will create measures as needed. If you need a persisted column, consider creating a column in Power Query using the mQuery language before choosing a calculated column for model optimization. That's not to say that calculated columns are not invaluable, but use them sparingly. Keep in mind that DAX calculated columns do not compress as well as other methods. It is not an optimum practice to use DAX for calculated columns if you can use a different method. It might be better for performance to use the X functions such as SumX, CountX, MinX, and so on. They offer filters that can help with performance. A calculated column in Power BI is an extension of a table that uses a DAX formula to evaluate values for each row. It allows you to augment the data from different sources by creating a column that didn't originally exist. For example, let's say you have a sales transaction table with columns like order ID, product ID, quantity, and unit price. However, there's no column for the total price amount per order. Using DAX, you can create a calculated column called total price by multiplying the quantity and unit price values for each row in the sales table, as shown here. To create a calculated column, select the ellipses button on the table in the data pane and choose New Column. Replace the default column equals text with the desired DAX expression. Like shown here, total price equals sales quantity multiplied by sales unit price. Here is the results. Calculated columns are a type of custom column. You can create custom columns in 3 ways. The best performance would be having it created at the data source so that it's available for you to import it in. Or you can even use a view created at the data source that you can call from Power BI and have it create the column as you import it in from the data source. The next best performance would be using Power BI's native language M to create the custom column. Last in performance is creating the calculated column using DAX in Power BI. Creating a calculated column in Power BI using DAX doesn't require semantic model refreshes to see the changes, unlike the other methods. However, it's important to limit the use of calculated columns due to potential performance impacts and increased data refresh time when dealing with a large semantic model. Calculated tables in Power BI are tables that are created based on DAX expressions or calculations. They are stored as part of the model and remain static until your data model is refreshed. Calculated tables can be created manually by writing DAX expressions or by utilizing functions like Calendar Auto, as shown on this slide. Calculated tables can be used to extend or enhance the data model by incorporating additional columns or performing complex calculations. They are useful in scenarios where you need to generate new tables based on existing data or perform calculations that are not easily to achieve with regular measures. By leveraging calculated tables, you can provide more flexibility and analytical capabilities to your reports and dashboards. Note here in our slide on the data pane, we have the calculated table called Date. You can tell it's a calculated table because it has a calculator in front of a table as its icon, and it is outlined here in green. Here is an example of creating a calculated table using DAX. Notice that we're using data that is already in our model. We have two tables here, Northwest employees and Southwest employees, and we'd like to add these two tables together into one new table. Notice when we do this, the calculated table will be stored as part of the model and therefore will not be calculated on the fly. Please note that the Northwest employees table and Southwest employees table both have 4 fields: employee, city, state, and tenure. Note too that we can create the calculated table by using the Table Tools menu and the New Table button off the ribbon on the Data View pane. Notice that there are 6 records in the Northwest employees table. And if we add it to the 4 records in the Southwest employees table, it will equal 10 records in the new Western Region employees table. Notice too that the Western Region employees table was created by using the DAX union statement that includes Northwest employees and Southwest employees. This will create a new table, as you can see it listed on the right, Western Region employees, with a green circle around it. What's another way to accomplish this? You guessed it, append. Now you may want to complete the Create DAX Calculations in Power BI Desktop Lab. You'll create calculated tables, calculated columns, and simple measures using DAX. Remember that you have access to the lab files and lab steps in GitHub. You also don't have to complete the previous lab before completing this lab. Are you ready for the DAX knowledge check? Question 1. Which statement about measures is correct? Answer: measures can reference other measures directly. Question 2. Which of the following statements describing similarity of measures and calculated columns in an import model is true? Answer: they can achieve summarization of model data. Let's recap this section. We started off this section by introducing you to DAX. We then talked about how to create the 3 different types of measures: implicit, explicit, and quick measures. Next, we discussed creating calculated columns using DAX. We then compared and contrasted our calculated columns and measures, and rounded out this section with how to create a calculated table using DAX. Thank you for joining us. See you in the next section. Now let me do a few demos in Copilot with some Power BI specific prompts. Now let's talk about using Copilot as a way to help you learn, study, and even prep you for working with the exam if you'd like to take the PL300. I'm currently in Bing, and from Bing in my Edge browser, I can easily get into Copilot. Once I'm in Copilot, you're going to note that there are two modes. One mode is for the web, where I can have it search the web for help on the information and questions that I might be asking right now, looking for specific information. The other one is work, and that the work tab allows us to query information about your work, and that would be your email, Teams, Outlook, files that you've created, people that you work with, and that requires a Copilot license to be able to use. So we're going to use web for our purposes here, and in particular, this is an option that doesn't require a license. So you could use it whether you have a license or not. And you don't need a license here for web in order to use it. So what I'm going to do is I would like Copilot to be my assistant here at work, and I'm going to go in and ask it a number of questions, and I'm going to have it help me right now. I'm going to pretend that I'm new to Power BI, and I really want to find out what are the top 5 things that I should know. And I'm going to narrow down where I want it to look, and I'm going to ground it saying asterisk.microsoft.com. So I'm telling it my current scenario, new to Power BI. I'm asking it what I want. What are the top 5 things that I should know? And then I'm telling it where I'd like it to look. And I'm going to ask it specifically for Microsoft resources. And I'm going to go ahead and execute that. And let's see what it comes up with in just a moment here. So it tells us to understand Power BI, we might want to look at some of these components. We're going to see some of those today if you haven't already taken a look at them. The desktop, the service, the mobile app that you can use to get connected, Report Builder. That's another option we have for paginated reports, creating those. And then Report Server, and then the on-prem version of Power BI reporting option. So for publishing reports, and then it gives us some basic concepts and terminology. It talks to us a little bit about connecting data sources. These are all critical things to know, the terminology. Speaking the language of Power BI, connecting to data sources, creating and sharing reports, and then some additional learning resources. Now I could have asked it to be a little bit more verbose and kind of fill out some of this information, but we do have some links at the bottom that we can use that might be very helpful. So it gives us some links to take a deeper dive, basic concepts and training. And so that's one question. Another question I like to ask it is where we're going to go eventually, and that is working with DAX and calculated tables in Power BI. And sometimes what happens is that we need to have a little bit of practice, or we didn't get a chance to read all the content. So now we're going to work with the courseware, and this is one of the links in our courseware, and it's for working with calculated tables. And I wanted to summarize this link into 5 critical to know bullets for working with calculated tables. So it's very specific what I want it to do, where I want it to look, grounding it in that information. And then as you can see, it's going to have 5 points. So I could have asked it for more points or less, but I only asked it for 5. And I could go back and then give it some extra questions that we could ask that might give it a little bit more detail. But showing here, you have 5 critical points to know. The purpose of the calculated table, what it's used for, how to create it. Unless you have some links here that you can get into very easily, you have some links here that you can get into very easily, or down into the bottom, relationships, the formulas, recalculation, and refresh. These are critical points that I found here in MS Learn, the path, so we can tell it specifically where to look, and that's where it found this information. We could have kept it a little broader too if we wanted to. Maybe just the asterisk.microsoft, that would have worked too. And then another top of mind query or prompt that I think about right now is that I'm going to tell it, Copilot, that I'm studying for the PL 300 exam, which is the Power BI exam. And I want it to create 3 multiple choice questions about modeling, a very critical component to our exam. And we're going to talk about it in our content coming up. And I want it to include answers with detailed explanations. And I'm going to tell it to look where to look, so that this is part of our courseware. So I'm having it quiz me on my courseware. So I'm going to go ahead and run that, and notice it's giving me just the 3 questions and the answers, and then the explanation, which is a very important part of this. But I'm going to tell it, but I told it only to give me a couple questions here given the data. So I'm going to go look at the links, and then it will give me where it got the questions from. That's our courseware. So what is the primary purpose of creating relationships between tables and Power BI? And it gives me multiple choice, and it tells me the answer is B, to enable data to be filtered and aggregated across multiple tables. And then it gives me a thorough explanation. And I could query it again, keep talking to the Copilot about the answer and why that answer was correct. Maybe I could ask it also, why are some of these answers correct and the others wrong? And give me an explanation for both of those and all of those, which ones, why this is correct and why this is wrong. So that's another way to work with this. And then you can copy this information and put it into your own words. So you have a running list of questions to help quiz you and to prepare you for the exam. You can also, of course, compare and copy what you've typed before. And you can use that to create another short demo here in Copilot, but hopefully a very practical one, as you can see here. I hope you enjoyed this small demo on Copilot and saw a few things that you can do to assist you in learning more about Power BI. See you in the next section. Thank you.